What we are going to talk in generative AI or Gen AI is large language models. We'll start from language models and move towards what large language models are. We'll briefly talk about how these large language models are trained. Then we will try to understand how these large language models could work with multimodal data, which leads to Gen AI, the functionalities of Gen AI. And then we'll try to understand some applications of Gen AI. So what is Gen AI or what is generative AI? Generative AI refers to a subset of AI that focuses on creating new content or data that is similar to what it has been trained on. So a Gen AI model that is known to you, I would expect that you might be aware of, say, ChatGPT. You can use that model and create information. When it creates information, it would create information based on what it has seen during the training process. That's why some Gen AI models tend to recreate content from the web. So what does Gen AI involves? It involves using algorithms to generate text, images, even music, and some other forms of media. More so, we'll really find that some of the Gen AI models are creative in a lot of sense because they are creating content which are novel. One of the examples is what I'm showing. So this is a picture which I created using ChatGPT, using DALL-E model, which uses the prompt that I have written there. Now, as you can see, first the quality of image is really good, but more so, it almost creates a content which does not exist, but yet is very similar to what would exist in a real world. Gen AI is based on large language models, which are derived from language models. Now, we have already talked about what language models are, which is about predicting in very simple terms the next word given the last few words. If that is a language model, then what would be the large language model? A large language model is a language model that has large number of parameters. And if you remember the neural networks class, what are the parameters? These parameters are the connection weights in a neural network, in a feed-forward neural network. Now note in this case as well, we may not work with feed-forward, a simple feed-forward neural network, because there is specialized requirement to handle large amount of data so that these large language models could be used and trained. So what are large language models? Large language models are a class of AI models designed to understand, generate, and manipulate human language. They commonly work with human languages, though some aspects of these large language models, for example, the architecture of transformer could also be used with other modalities like images and audio. And that is why these large language models cannot just take input from one modality like text, but also can take input from multimodalities, which is also important because often the data on the web, on the internet, has multimodalities. There are a lot of videos which are present. There are a lot of images which comes with captions. There is a lot of text which has associated images to it. And a large language model, which is based on an architecture which is generalizable like transformers, can work with multimodalities. An LLM typically uses architecture like transformers, which allow them to process and generate text efficiently. Transformers use mechanisms like self-attention to weigh the importance of different words in a sentence, enabling the model to understand context and relationship between words. And I'll give you a very simple example. Many words could be used differently in different contexts. For example, a word like light. A light could mean the visual light, could also mean in terms of weighing, a lightweight object. A model which is based on transformer has a way to understand the context and thereby able to make predictions which are better than other models that are used for languages. We talked about recurrent neural network in some time back. So they can understand the context because often the meaning of the word is represented by the context in which the word is present. These models are trained on extensive and diverse data sets, which can include books, articles, websites, and other text across the internet. The broad training, the data that's coming from different sources, also helps us to generalize to various language tasks. So that's an advantage of large language models. Now, many of these large language models are based on an architecture called transformer. Now, I alluded that in my last slide. Transformers are based on a research paper published in NeurIPS conference in 2017 by Vaswani et al. And the title of the paper is Attention is All You Need. So in the next few slides, what I'm going to talk about is content basically coming from this paper, which again gets used in recent advanced large language models. So what are the key components of transformers, which are like the building blocks of large language models? Now, if you want to relate these transformers to what we already know, think about it like a specialized architecture which is designed to handle large amount of data. Just like we envisioned convolution neural networks which can handle image data, and we thought of recurrent neural networks which can handle text data. Transformers can handle text data, but it allows them to use text not in a sequential order. If you remember recurrent neural networks, it had a sequentiality to it. It would take one word as an input, the next word as the next input, third word as the next input. In contrast, a model like transformer allows you to take the entire text as one input, which is advantageous because first it makes it much more efficient. So what is a transformer? Transformer is composed of an encoder block and a decoder block. Transformer encoder is designed to process sequential input data and generate contextualized representations of the input, capturing relationships and dependencies between different parts of the sequence. Just like I was talking about the word light, depending upon the context in which it's getting used, it can have a different meaning. A transformer has 5 different components which we should talk about. It has encoder, it has decoder, it has a multi-head attention, which is an extension of self-attention, and it has positional encoding, and it has input embedding. So let's briefly look at what these are. What is an encoder? In the context of transformer architecture, the encoder is a component designed to process and transfer input data. An encoder, as the name says, takes the input and encodes it. Encodes it in some representation, which we call as contextualized representation. And often these representations are like numeric representations, which are a number or a set of numbers that represent something. These representations capture the relationships and the dependencies between different parts of the input sequence, just like we talked about earlier, making them useful for a variety of downstream tasks, for example, translation, classification, and others. So in a way, what is encoder doing? Encoder is encoding the information that's coming to it in a useful representation which could be used for the next part, which is the decoding. What is a decoder? A decoder is designed to generate output sequences, which could just be text outputs, from the encoded representation of the input sequences. So what's happening here is, we have encoder and we have decoder. Encoder is encoding the information in some representation, and that representation is getting used by the decoder to decode that information, and that decoder generates output. If you think about ChatGPT, this is what's happening. An encoder here is the prompt that you provide, which is in the form of text, gets encoded. That encoded information is getting passed to the decoder, and that decoder starts to generate the output that you see. The decoder processes the encoded information and produces the final output step by step, while attending to both the encoded input and the previously generated tokens. Now, a multi-head attention is one of the important blocks of this transformer model. So what is a multi-head attention? Multi-head attention is based on self-attention. Self-attention is a mechanism within neural networks, particularly in transformers, that allows each element of a sequence to consider and weight the importance of every other element in the sequence when processing the data. It enables the model to capture dependencies and relationships regardless of their distance in the sequence. If that is self-attention, then what is multi-head attention? Multi-head attention extends the concept of self-attention by using multiple attention mechanisms or heads in parallel. In addition to encoder, decoder, and multi-head attention, we also see that there is something called an encoding, a positional encoding. So what is a positional encoding? Positional encoding is a technique used in transformer models to inject information about the order of the sequence into the model. And why is that important? Because as I said, transformer takes the entire text as input, unlike a recurrent neural network which takes one word at a time. So recurrent neural network has information about the order. However, if you pass the entire word set from a text as the input, it does not preserve the ordering. And to get the information about the ordering, it adds something which is called positional encoding, which provides information to the transformer model about the ordering of these words. What is input embedding? Input embedding, which is the input to the model, is the process of converting discrete tokens, often words or characters when it is text, into continuous vector representation in a high-dimensional space. You will almost always use embeddings as the input to most neural networks. Why is that so? Because neural networks don't understand text or words in that sense. Even when I was talking about recurrent neural networks, and I said that the words are the input, I really mean that the embedding of the word is the input. And what is an embedding of a word? It is nothing but a numeric representation that represents that word. Though it's unique in a sense, it preserves that this word is only going to have this representation. So different words will have different representations. And in the case of transformers, each token, which could be a word and a combination of words, is mapped to a fixed size vector that captures its semantic meaning. That is what the embedding I'm talking about, enabling the neural network to process and learn from the input data more effectively. So now that we have seen all different aspects or parts of the transformer model, the question is, how does it get used? As we know, the primary two components are the encoder and the decoder. You train the model with a lot of data. And how is that data going to look like? For example, you get data from websites which are based on question answering. So your input data is going to be questions, and your output data is going to be, expected output data is going to be the answers written for those questions. And then you have the entire web. You get all information from the web. You have large volume of data, and you train these encoders and decoders. Now note, these encoders and decoders also have multi-layers. So it's not just one layer that's being shown, but we are showing that there is n layers to it, which is why these are large language models, because there are a lot of parameters. But if you have a large volume of data, if a large amount of data is available, you could still train these models. And once you have trained these models, now what you have is a trained large language model. And a model like ChatGPT is just a large language model that is giving you a web front which allows you to interact with this model. However, ChatGPT or models like GPTs are not the only model. Before this GPT got popular, we had BERT. BERT was a very popular model used for many tasks, including like sentiment classification, named entity recognition, question answering. So what is a BERT? BERT is a deep learning model developed by Google for natural language processing. It stands for bidirectional encoder representation from transformers. Now it is also based on transformers, but the design, the architecture is different than what we have for GPT models. Now the question that you might have is, when do you decide which model to use? Now the rule of thumb is that it's generally good to try with more recent models. At the same time, more recent models tend to be large in terms of the number of parameters that they have. So unless you have data that can support to train this model, you're not likely to use large, more recent models. So you might want to evaluate your options, which is a model which is big enough, which can be used to train based on the data that you have. Now, if you're working for a small company or if you're a student at universities, you might not have resources to train a large model. Even a model like BERT, it might not be possible to train it from scratch. So what do we do in that case is something called transfer learning, where we first take a pre-trained model, which is a model that has been trained on large volume of data set and has been shared by some large firms like Google and others. They shared this model. Now this model, as you know, is a neural network, which means that it has all neurons and connections and you have those weights available to you. What we do is we tune it. In a sense, we don't train these models from scratch. Whatever small data set that I have or the problem that I am interested in, I will use that data set and then retrain some parts of the model, usually the last few layers, to work on my problem. For example, let's suppose I have a very unique sentiment classification. I have a textbook on different types of plants, and I want to know what is being written about that plant is positive or negative in terms of sentiment classification. Now, this might not be appropriate for general sentiment classification because the terms that get used when describing plants are going to be very different from the terms that's used for other tasks of sentiment classification. So what you need to do is you take the data set that you have and get some labeled examples. You can't train a model without labeled examples. So you would have some data for which you create labels, and then you take a model like BERT, and for the small data set that you have, you tune that model, which means that you train that model for a few epochs. And usually we do that for the last few layers. In some cases like BERT, it provides some way to train which only trains the last few layers of the model. So this is how we use an existing large language model. But what we have not yet covered is how are these large language models trained? If you are working on a data set that's available to you, you are likely going to use that data set to train the model. However, these models are really large in terms of the parameters that they have. So a small data set, even if it's like GBs of text, is not sufficient to train a large language model. So what we do is generally multi-steps. These involved first learning just based on the data on the web. So a large language model that uses data on the web to train itself. And once that training is done, then we train based on specific tasks. Now I have showing some tasks for you. For example, we have sentiment analysis, we have text summarization. Some of these tasks are available on the internet, and prior researchers and companies have created dataset for these. So you take a model which has been trained on large amount of data available on the web and then train it further on the task that is at hand. So you improve the model to work on some of the tasks that's important for you. However, that's not it. Sometimes these models are also trained based on human feedback, what we call as reinforcement learning from human feedback. And the way that works is that these companies would have some data about, given some input, what is the right output or the set of outputs which can be ranked. Now these rankings of the outputs are then again used as human feedback to train some parts of these models. So as we just talked about, these large language models are first trained on large volume of data which is available on the internet, but then they can also be trained on information available based on human feedback or tasks which are already available and for which we have data accessible. Now I've been talking about these large language models and saying that some of these models have large number of parameters. But what is the range of parameters that we're talking about? Now in this plot, I show how these large language models and the size of large language models have evolved over time. The last GPT-3, which was released a year or so back, had approximately 100 billion parameter. Right? 100 billion is still pretty large, but more recent models that we are talking about parameters which are in order of trillions. So we're talking about thousands of billions of parameters. So that's where the current state of the art is. The next question that could come to your mind is, these parameters are too many, but how do they compare to human brain? Now, there are different estimates of parameters or neurons and the connection which exist in human brain, but approximately the order is of hundreds of trillions, which means that we are still using models which are smaller than human brain's capacity in order of 1 by 100. So it will still take us a few years to really reach the capacity that a human brain has. I think it's a very exciting time in which we are living, And very soon I would expect that we will have models which will have hundreds of trillions of parameters which are comparable to what a human being has. And it will be good to see what these models can achieve. Now that we are familiar with large language models, the question comes to us as, where can they be used? Now, the large language models, which are sometimes often called foundation models, are trained on diverse data, which means they have already seen text, images, speech, and other structured data. Which also means that these models could be used for a variety of purposes, which is why you see that these models could take text as the input and then create images. Some of these models, if you look around like Sora, they can take text as the input and create videos. These models could also be used for sentiment analysis and other traditional tasks that we had in natural language processing. But these models, the foundation models, are truly multi-purpose. They can be used for tasks, sometimes which the developer of this model might not even have envisioned for, because they have seen the pattern of those tasks in the data that they have been trained on. There are multiple models, multiple large language models, which means it's good to know how they compare against each other. So I have this slide, which is obtained from OpenAI community website, which talks about how Claude 3 compares with GPT-4, GPT 3.5 and other models. Now that you know about large language models and how they work, it's good to know about what are the different large language models that exist. Now GPTs are very popular because of OpenAI and the ChatGPT interface that they have provided, but there are many models which are very good and comparable in a lot of sense. So in this slide, I compare some of these models. We see that Claude 3 is comparable to GPT-4 in many of the tasks. We also see that Gemini models, which are from Google, are also comparable in a lot of these tasks, which means that in the future, we will not just have one option, but multiple options that can be evaluated for the tasks that you will have at hand. I'm sure the future is very exciting for all of us. I have already covered some of the applications of Gen AI. In this case, I will just reiterate a few. Text generation is a common case. Text generation is where you pass some input and expect the model to output text, which could be like a ChatGPT prompt. You provide a prompt and expect the model to return you information in terms of text. Image and video generation is again something you have seen. Music and audio generation are less heard of, but are becoming more and more popular. In fact, recently, I got to hear the voice generated by OpenAI models, and it is unbelievable how good they are. They don't just include what the words are in the text, but also the emotions that a usual human being would like to have while talking about a context. Now that you know what are the common use cases, let me connect it back to some of the slides that I started with. The common applications of AI, and now that you know these are Gen AI models. So we started with AI chatbot. Now you know what this AI chatbot is. What is this chatbot? This chatbot is generating text as an output, but on the back end, this is a large language model. And what is a large language model? A large language model is a language model which has a lot of parameters and which has been trained on a variety of data sets. What is a model like this which can create videos? Videos are also based on generative AI. Generative AI uses foundation models as we talked about. And in this case, it will use text as an input to generate a video like what you're seeing on the screen. Again, a great application of generative AI. And lastly, I want to briefly talk about an example where we could generate text and images together. So in this case, what I did is I wrote a prompt on ChatGPT asking first it to create a story. And once it has created the story, I asked it to create an image for each of the paragraphs in the story. And it was a few lines of prompt, and that allowed me to create beautiful stories. An example of that what you're seeing right now on the screen. We are getting close to the end of this module, and I want to summarize what we have learned so far. If you remember, we started from machine learning. We tried to come up with where is machine learning positioned in terms of artificial intelligence. We got to know that machine learning is a type of artificial intelligence which uses data to learn from. Then we talked about deep neural networks or deep learning, which is again a small part of machine learning which uses deep neural networks. We talked about neural networks. We talked about how neural networks have different architectures and designs, and how many of these are adapted for different tasks at hand. For example, convolution neural networks for image processing and recurrent neural network for language processing. We also talked about more recent models like transformers and how they can be used to train on a large volume of data sets. Now, some of these models form what we call as foundational models. These are the core of generative AI. Generative AI uses these transformer-based models to generate new content. However, that's not all. We are yet in a phase where there is a lot more is about to come. And for this, I would like to share this slide which was shared by Professor Ian LeCun. He says that reinforcement learning, if you think there is a cake, and reinforcement learning is the cherry on the cake. It's a very small part of the entire machine learning that's happening right now. The supervised learning is like the icing of the cake. It's still a small part of it. Most of the learning that is happening is from unsupervised data, which is the rest of this, is the cake itself. So most of the learning is happening based on unsupervised predictive learning, which allows us to train those large language models and transformer-based models that we are talking about. And that's also the future. Supervised learning, which requires labeled data, is expensive. It's not always possible to have those labels. So that's why the future is going to use more and more of data which is unlabeled and comes in the category of unsupervised learning. And the applications of these are already visible to us in terms of large language models and other generative AIs. So that's all for this module. We covered many important aspects. We covered machine learning, we covered supervised machine learning, unsupervised machine learning, we covered deep learning, we covered large language models, and we covered generative AI. I hope you enjoyed the course, but more so you really learned about these different techniques of machine learning, the different aspects of machine learning.
Hello everyone, welcome back. Now that you understand how language model works, let's go into the types of models and the model evolutions that have happened. To give you some brief history. Have you ever wondered how AI models like ChatGPT became so powerful? How did we go from simple chatbots to AI that can generate essays, crack jokes, and even pass exams? Today, we'll explore the evolution of large language models or LLMs and see how they've transformed over time. Earlier, there used to be language models just to predict a few words at a time, and now you have cutting-edge GPT-4. Let's start with the very beginning. The early foundations were actually between 1960s to 1990s. The story of LLMs begins in 1960s with ELIZA, the first natural language processing program. This was developed by Joseph Weizenbaum at MIT. ELIZA was a simple chatbot that could mimic human conversation, though it followed rigid scripts. It wasn't truly intelligent, but it laid the foundation for future language models. Fast forward to 1990s, and we see the rise of statistical language models like n-grams and hidden Markov models. These were key advancements that allowed computers to predict the likelihood of a word or a phrase appearing in the given context. This era provided the groundbreaking work for more advanced systems. And then came the next phase called the neural network renaissance. This was a phase that lasted from 2000s to 2010s. In the early 2000s, neural networks became popular for language tasks. This was the start of AI models becoming more sophisticated. By 2010, Stanford's Core NLP suite introduced tools for complex natural language tasks like parts of speech tagging and sentiment analysis. Around the same time, Google Brain launched, and it provided researchers with powerful computing resources for AI and NLP research. These developments set the stage for next big leap, that is the transformer revolution. What is a transformer revolution? And this is something that lasted from 2017 to the current time. In 2017, a game-changing paper introduced the transformer architecture. This technology revolutionized natural language processing by allowing models to process language more efficiently and handle longer contexts. Transformers are the backbone of modern LLMs, including GPT models. In 2018, Google's BERT was the model that set new benchmarks across all various NLP tasks. It introduced the concept of bidirectional understanding, meaning the model could consider both the left and the right context of a word simultaneously. This was not there until then, and this was a breakthrough. And then came 2019 with OpenAI releasing GPT-2, which shocked the world with its ability to generate coherent and human-like text. People realized these models weren't just good at understanding language, but they could also create it. Then came GPT-3 in 2020. With 175 billion parameters, it introduced few-shot and zero-shot learning, meaning it could perform tasks it hadn't been explicitly trained on, just by understanding a few examples or even just a task description. Then came the next phase, which is a current phase, the rise of GPT-4 and the multimodal models. In 2023, OpenAI launched GPT-4, taking things to a whole new level. Unlike previous models, GPT-4 introduced multimodal capabilities, meaning it could process both text and images. For example, you could show GPT-4 a photo of a fridge and it would give you meal suggestions based on the ingredients inside. GPT-4 also demonstrated advanced reasoning abilities, passing standardized tests like the bar exam and SAT. It even started learning humor. Yes, AI-generated jokes are a thing now. One of the most exciting features of GPT-4 is steerability. This allows users to customize the model's behavior, making it act like a professional writer, a teacher, or even a pirate if you want. This customization opens up endless possibilities for practical applications. Now, does bigger mean better? When you ask a question, if a bigger LLM means a better LLM, you need to understand that the answer seemed to be yes in the early days. The only original GPT had a few million parameters. GPT-2 had hundreds of millions, and GPT-3, as I mentioned, had 175 billion parameters. And today, Megatron Turing, developed by NVIDIA and Microsoft together, has 530 billion parameters together. But here is the twist. Bigger isn't always better. For example, DeepMind's retro model showed that smaller models can outperform much larger ones by using retrieval-enhanced training, which allows the model to access external data during responses. Retro has just 7.5 billion parameters, but it outperformed models like GPT-4 that are 25 times its size on several tasks. In fact, after GPT-4's release, OpenAI CEO Sam Altman suggested that we've reached a limit in terms of building larger models. But why? Because we are running out of high quality data to train them on. Instead, the future lies in smaller and smarter and more efficient models. Now that you have some history of LLMs, let's look at the types of LLMs there are. LLMs can be classified into different types based on architecture or purpose and access. First, let's look at this categorization of open source versus closed source models. Open source models are accessible to the public and allow for collaborative development. Examples include Bloom, Falcon, and Meta's Llama. On the other hand, closed source models like GPT-4 and Google's Lambda are proprietary and not available for public use. What does open source and closed source actually mean? It means that we have access to how the data is trained on in an open source model, while a closed source model can be only accessed through APIs that the companies provide to it. And then we look at a different classification of these models called the general purpose versus domain specific models. General purpose models can handle a wide range of tasks across various domains. Examples for general purpose models could include GPT-3 or BERT or even Palm by Google. But there are domain-specific models as well. And domain-specific models are tailored for specific industries like healthcare, law, or even finance. These models are fine-tuned to excel in specialized tasks. And that's why they can be used in that context alone. And then, another categorization could be based on the architecture of these models. In this classification, one of the types is transformer-based models, which are the most common ones these days. They use the transformer architecture to efficiently process sequential data. Examples include the entire GPT series, BERT, and P5. And then, there are other kinds of models which are called mixture of experts or MOE. These models are multiple specialized submodels for different tasks. For example, take Google's Palm and Grok from XAI. When they have multiple mixture of experts, you call different models for different tasks and perform them there itself. Now let's look at popular LLMs that you should know about. Let's take a quick look at some of the most notable LLMs across the spectrum that are available to us today. The first and the most popular one, of course, is the GPT family by OpenAI. These are transformer-based closed source models. And the most notable ones amongst these include GPT-3 and GPT-4. And then comes the Google's BERT. This stands for Bidirectional Transformer, and it's an open source LLM. This is used for tasks like sentiment analysis and question answering. And then comes Palm by Google, which is not a transformer but a mixture of experts kind of a model in its architecture. This is actually a closed source one and which has up to 540 billion parameters. This is used for translation, summarizing, and way more. Then comes Llama by Meta AI. This is a complete open source and transformer based model, and the versions include Llama 1, Llama 2 with up to 65 billion parameters. They recently released Llama 3 as well. Another example of mixture of experts could be Grok 1. This is done by XAI. This is a closed source model. It has 314 billion parameters and integrates directly with X, formerly known as Twitter. Then you have Mistral 7B and Mixtral. This is done by Mistral AI as a company. These are open source models that focus on efficient deployment of various NLP tasks. Now that you know how and what different types of LLMs exist, let's look at how do we train these large language models. So how are LLMs actually trained? LLMs are trained on massive amounts of unstructured data through something called self-supervised learning. Here is how it works. The model is fed long sequences of text where certain words are missing, and it predicts the missing words based on the context. Over time, it learns to recognize patterns and generate coherent responses. But how much data do you think you need to train a large model like this? A study by DeepMind found that most LLMs are undertrained. Their research showed that the best performing models balance model size and training data. This is known as compute optimal training. One famous example is Chinchilla, a model that used fewer parameters but 4 times more data compared to its predecessor, Gopher. Chinchilla significantly outperformed Gopher while reducing costs. Now let's think of where these LLM models are actually going further. So what's next? We are actually moving away from building giant models to creating more efficient, customizable models. With advancements like steerability and multi-model capabilities, the possibilities for LLMs are actually endless. The evolution of LLMs show us that AI is advancing faster than ever before. We have moved from basic chatbots to systems that understand language, images, and even humor. The future of AI is here, and it's only getting smarter. Thanks for watching and stay curious. We'll see you in the next video. LLMs have revolutionized the AI landscape, enabling businesses and individuals to harness the power of advanced natural language processing. However, deploying and maintaining these models comes with significant costs. Here, we will comprehensively break down these costs associated with various LLMs, helping you better understand their pricing structure and implications for different use cases. So let's get started with types of LLM costs. The first type of cost that you incur when you deploy an LLM could be your infrastructure cost. This basically is the operation of LLM requires a robust infrastructure which includes high-performing GPUs, CPUs, and cloud services. These components are critical for ensuring that models can handle large amounts of data efficiently and deliver results very quickly. So infrastructure costs can be divided into, again, further two main categories. One is training costs and the other is inference costs. Training costs refers to the computational resources required to build the model from scratch or fine-tune an existing model. Cloud providers like AWS, Google Cloud, and Azure charge for these resources based on GPU hours that you use, making this a significantly expensive process for a regular organization to incur. Other side of infrastructure costs is inference costs. These are incurred each time a query or a prompt is processed by the model. These costs grow with the frequency and complexity of queries, making them a crucial consideration for high traffic applications. That is about infrastructure costs. Then you have cloud-based API costs. Many organizations choose to utilize pre-trained LLMs provided by companies like OpenAI, Anthropic, or Cohere, as building blocks from scratch can be prohibitively expensive. We've seen how expensive some of these infrastructure costs can be. These providers offer access to their models via APIs, and the costs are primarily based on token usage. Tokens represent fragments of words, and the cost is calculated per 1,000 tokens processed. The pricing also varies depending on the size of the model. For example, larger models such as GPT-4 are significantly more expensive than smaller models like GPT 3.5. This distinction allows users to select a model that balances costs with performance based on their specific requirements. Now, let's look at the costs associated with custom model development. Organizations that require LLMs tailored to their unique needs more often than not invest in custom model development. This process involves costs related to data collection and cleaning as well, which ensures that the training data is indeed relevant and of high quality. Additionally, fine-tuning the model for a specific business need demands expertise and computational resources. Once the model is deployed, regular updates are necessary to keep it relevant and effective, which adds to the ongoing expenses anyways. That's the third kind of costs. The fourth kind of costs will be operational costs. Beyond initial development, operational costs play a significant role in overall expense of how you use LLMs. These costs include continuous monitoring of model to ensure optimal performance and scaling resources to handle fluctuations in user demand, for example. Furthermore, addressing challenges like model drift, where the model's prediction becomes less accurate over time, requires active maintenance and high interventions. Human expertise costs are the next costs. The successful implementation and optimization of LLMs required skilled professionals. Teams comprising data scientists, machine learning engineers, and product managers are essential for designing, deploying, and maintaining these models. And the salaries and expertise of these professionals represent a significant high cost for organizations which utilize LLMs. Now let's look at how these LLM costs can be broken down and what are the prices for different kinds of LLMs available for us in the market. This particular table should give you overview of how these are priced. For example, the models of OpenAI, which is GPT 3.5, 4 and 4 with 32K tokens, are priced in this way. They are all priced per token, And for GPT 3.5, this is how much you pay for input tokens, and this is how much you pay for the output tokens. Which means your prompt can be small, but your response can be large. Sometimes your prompt is large and your response can be small. Either ways, they are charged separately here. Similarly, the costs are obviously higher for GPT-4 and even higher for GPT-4 with higher number of tokens capability. Then here you can see the cost for Claude 1 by Anthropic, which is going to be charged at $0.11 for every 1,000 input or output tokens. It's the same charge. And you can clearly see here, sometimes some LLMs actually charge for subscription. In that case, you basically pay a one-time fee which can be used for whatever prompts you use, right? Then this custom pricing is generally based on tokens and model size, similar to what OpenAI does. Interestingly, Google Cloud AI, which is based on Palm 2 model, prices you per query rather than pricing you per tokens. So there are different pricing models that exist, but here you can clearly see the most common one is actually pricing by tokens used. Now this is for an organizational implementation of cloud APIs, where you will use these models using APIs and access them, and therefore you'll be charged based on this. Now we can look at what would probably the cost for personal use of these models will be. Very quickly, these models can be used for different activities when you're using them on a personal basis. For example, OpenAI's ChatGPT Plus subscription comes at a $20 price, and it provides you access to GPT-4 for personal use, including enhanced performance and priority access during high traffic. If you look at Claude, which is by Anthropic, it has a free tier with limited usage, and the paid tiers generally for higher usage limits. Google's Bard, for example, is actually fully free to use with Google account. Some enterprise features are available at a custom pricing for Google Bard. Then you also have Hugging Face Interface API. Hugging Face is basically a platform where you can find pre-trained models. People come and upload their pre-trained models there. If you use Hugging Face Interface API, then this offers free tier access to community models, and there are paid models which start at around $9 a month with higher usage tiers for advanced users. Now let's look at factors influencing these costs. To summarize it all, model size and complexity are one of the main factors that influence the costs. The size and complexity of an LLM directly impacts the costs that the user will incur. Larger models like GPT-4 require more computational resources, making them more expensive to use. Because these models offer superior accuracy and contextual understanding, it is understandable. Smaller models may be sufficient for less demanding tasks, offering a cost-effective alternative. The second thing that affects costs is usage patterns. The cost of using an LLM is heavily influenced by how frequently it is used. For example, applications like customer support bots, which process a high volume of queries, incur substantially high costs. In contrast, occasional use cases such as generating a one-time report result in lower costs. So it depends on where you are deploying your LLM models to work. The third thing is your customization needs. Customization can actually significantly increase your costs. Fine-tuning a model for domain-specific tasks require additional computational resources and expertise. So, periodic retraining is necessary to maintain the model's relevance, and this also further adds to the expense. Then we have the deployment scale, which is also a reason for higher costs. Organizations operating on a global scale often need to deploy LLMs across multiple regions to ensure low latency and high availability. This level of deployment requires substantial infrastructure investment and increasing the overall cost for you. The next is the media type. The type of media that models process, be it text, audio, or video, also impacts the costs. Processing in audio and video typically demands more resources than text due to larger data sizes and complexity. The next thing is latency requirements, which is how quickly do you need the response from the model, and this also influences costs. Lower latency requires more computational resources or optimized infrastructure, which can be more expensive to maintain. Therefore, there are higher costs for this. Now let's look at a table which will kind of give us a sense of how much money it probably costs for different applications. Here you can see how chatbots, which use around 10 million tokens on a monthly basis, you could probably be charged around $15,000 to $20,000 in LLM costs. If you actually are doing document summarization, which has way more tokens, but because documents are larger in size, you need to go for a model which has higher capabilities. Even if you use 5 million tokens, your costs will come up to around $150,000. And if you're doing real-time translation using something like a Palm 2, this requires around 20 million tokens in a month, and this can come to anything between $100,000 to $120,000. And custom analytics platforms using Claude 1 can be around $88,000. These are all estimated costs, but you can get a good sense of how much these tasks actually require to be deployed. Something to note here is that all of these costs, although they look high, they're still cheaper than deploying a human. And you have to figure out the trade-off between deploying expert humans versus models which can replace humans for certain tasks. We will talk about if humans are replacing AI or AI replacing humans later, but this should be a good introduction to think of it for a bit. Now, let's go on to the next part of understanding the costs, which is how do you even optimize the costs for your specific application. Here is a 4-step approach that I can suggest, which is first, choose the right model. Selecting the appropriate model for your task is a critical step in cost optimization. For less complex tasks, smaller models can be used to save on token costs without significantly compromising performance. In more demanding scenarios, a hybrid approach can be effective. Using smaller models like GPT 3.5 for simpler tasks and larger models like GPT 4 for more complex ones is the right way to go about. Then, second way to reduce or optimize costs is doing batch processing. Batch processing is an effective way to reduce inference costs. By grouping multiple queries into a single query or a single request, you can decrease the total number of calls to the model, leading to significant cost savings. Then you have costs that can be reduced by using open source alternatives. There are a lot of open source models such as Llama or Falcon that can be deployed in-house to eliminate API fees. While these options require more upfront investment in infrastructure and expertise, they actually offer long-term cost benefits for organizations, and that too with consistent and high volume needs, right? If you have organizations like that. That's another way to reduce costs. The fourth thing to do to reduce or optimize your usage is actually monitor and optimize usage. Regular analyzing of token usage is essential to identify inefficiencies and areas for improvement. By eliminating unnecessary queries or optimizing prompt structures, you can significantly reduce costs while maintaining performance. The next topic is actually about hosting an LLM in your own cloud. When it comes down to hosting your own model, the main cost, as mentioned, is going to be hardware for you. Consider, for example, hosting an open source model like Llama 3 on AWS. The default instance recommended by AWS is going to be something like ml.p4d.24x large with a listed price of around $38 per hour, which is on demand. This means that as such, the deployment would cost you at least $27,000 per month, assuming a 24/7 operation, assuming it does not scale up or down and that no discounts are applied. That is already a huge cost. Coming back, these are the ways that you can actually think of deploying model on your infrastructure or choosing a cloud-based API based on the overall cost that you are expected to incur. In conclusion, understanding the pricing of LLMs is crucial for making informed decisions. By carefully analyzing costs and optimizing usage, businesses and individuals can unlock the power of LLMs without breaking their budgets. This breakdown aims to provide clarity on economics of LLMs, empowering you to choose the right model and pricing plan for your needs. Have you ever wondered how to figure out if your ChatGPT 4 model or any other AI tool is better or worse than another? For example, if I ask you, hey, I think Claude is better than ChatGPT, what will your response be? How can you actually benchmark these models? Benchmarking is actually the answer for this. It's how researchers and developers test these models, compare them, and ensure they perform very well in the real-world tasks. Today, I'll explain how benchmarking actually works. We will highlight some of the top benchmarks and even show you how you can create your own custom benchmark. So let's get started. To start with, what is a benchmark? Let's start with the basics. Benchmarking is a structured way to evaluate a model's performance. Think of it like testing a car. You wouldn't just look at the engine or check how fast it goes in a straight line. You also want to test its fuel efficiency, handling, safety features, and way more. Similarly, for LLMs, we have to test them across many dimensions. Here is what those dimensions typically look like, right? There are 5 different dimensions that we end up looking at. The first thing is called accuracy. Accuracy basically means how does the model produce correct or reliable output? That's what it stands for. That's the first one. The second one is robustness. It stands for if the model can handle tricky inputs like typos or adversarial examples. Third is generality. How well does it perform across tasks it wasn't explicitly trained for, constitutes its generality. And then the fourth, which is efficiency. Does it perform well without using too much computational power, is the whole point of efficiency. And the fifth dimension that is generally looked at is alignment. Alignment are its outputs ethically and aligned with human values. Each of these dimensions is tested specifically using different benchmarks. Let me walk you through some of the most popular benchmarks that we have right now. To start with, let's look at a benchmark called GLUE. It stands for General Language Understanding Evaluation. This is like a high school exam for language models. It tests the models on basic language understanding tasks, such as, for example, sentiment analysis, which means determining if a sentence is like positive or negative. For example, it's like the movie was a total disaster is a negative statement about the movie. The movie was amazing is a positive statement. When you read a sentence which says the movie was a disaster, the model should be able to say that it was a negative statement. Then you can also look at something like text similarity as a dimension to see how well GLUE works, which is checking how similar two sentences are, like the dog is sleeping and a dog is resting. They are very similar in nature and the model should be able to figure out these are very similar sentences. Basically, GLUE combines results from multiple tasks into a single score, making it easy to compare models. However, as models improve, GLUE started feeling too easy. Most top models were scoring near perfect scores on GLUE. That's where its more advanced sibling comes into picture, and it's called Super GLUE. Super GLUE is a tougher challenge. It includes more complex tasks such as the Wingard schema challenge. Here is an example of what happens in this challenge. The trophy didn't fit into the suitcase because it was too big. What does it refer to? Models need to understand context to answer correctly. So that's one example of what this challenge has. Another thing can be multi-hop questions, which, for example, could be answering questions like, who won the Nobel Prize in physics in the year Albert Einstein received it? This requires combining information from multiple sources. Super GLUE is great for testing deeper reasoning skills and has become a new standard for evaluating advanced models. And now let's look at the next one, which is very popularly demonstrated in most of these LLM benchmark websites. This is called MMLU. This stands for Massive Multitask Language Understanding. MMLU tests how much a model knows across 57 different subjects, ranging from mathematics to law to medicine. Imagine a medical question like, what does a high white blood cell count indicate? A model needs domain-specific knowledge to answer this correctly. So, if a model is performing well on MMLU, it means that this is well trained. So, MMLU is particularly useful for specialized use cases like education or professional domains. If your model performs well here, it's probably pretty versatile, right? Next benchmark that we're looking at is called the Big Bench. The big here stands for Beyond the Imitation Game benchmark. Now, let's talk about the Big Benchmark, which is like a creative workshop for LLMs. It includes tasks designed by researchers all over the world, covering areas like reasoning, which can model and solve puzzles and riddles. The second dimension is ethics. How would the model respond to a moral dilemma? The third dimension is creativity. For example, generating a fictional story in a specific style. These are the three dimensions that are looked at. Big Bench emphasizes going beyond traditional NLP tasks and assessing more human-like abilities. The next benchmark is called Human Eval. For those of you interested in coding, Human Eval is a specialized benchmark. It provides coding challenges like write a Python function that calculates the nth Fibonacci number. The model's code is run against test cases to see if it's correct. This benchmark is widely used for evaluating models like Codex and GPT, which are trained for programming. The next benchmark is called HELM, Holistic Evaluation of Language Models. HELM doesn't just measure accuracy, but also looks at the following factors. The first is fairness. Fairness stands for, does the model treat all demographic groups equally? That constitutes fairness. Then it looks at efficiency. Efficiency is how much energy or computational power does it actually use. The third is multilingual capabilities. How well does it work in non-English languages? HELM is great because it focuses on real-world applicability and ethical considerations together. These are some of the benchmarks that you can popularly find in many of these online published benchmarks that you can look for. Now, let's talk about creating your own benchmark. This is useful if you are working on a specific use case like healthcare, finance, or education. Here are the steps that you can follow. Step 1 is to define your objectives. Start by asking, what do you want to measure? For example, are you testing domain knowledge in medicine? Do you need to evaluate ethical decision making? These are the kind of questions you want to ask in step 1. Step 2 is to curate a database or a data set. First, gather high quality data related to your objective. Let's say you are benchmarking a healthcare model. Your data should include or may include clinical notes, medical FAQs, scientific articles from PubMed maybe. These are the kind of things that you want to put together. Remember to include diverse examples to test the model thoroughly. Step 3 is actually choosing the metrics. Select metrics that suit your task. For example, For text classification, use accuracy or F1 score. For summarization, you can use something called rogue or blue scores. Let me give you some more information on what rogue or blue scores sound like. Blue is used for machine translation tasks where precision and fluency are important. Blue compares the number of n-grams, consecutive words basically, in the machine generated text to the number of n-grams in the reference translation. It calculates the precision of n-grams in the generated translation and normalizes it by the maximum possible precision. So that kind of gives you a score. Then you have rogue, which is used for text summarization tasks, where capturing key content is important. Rogue basically compares the overlap in unigrams, bigrams, and n-grams between the generated summary and the reference summary. It calculates recall, precision, and F1 score based on the number of overlapping n-grams. If you're not clear with the details of how these scores are calculated, that's okay. As long as you know that for this kind of tasks, we should be using blue or rogue as our metrics. Now, if we move to more open-ended tasks, use human evaluation to assess fluency and coherence. Then comes step 4, which is implement baselines. Before testing your fancy LLM, compare it against simple models. This helps you to see if the complexity of your LLM is even justified. Sometimes having a simple model is more than good enough. The next step is to automate evaluation. Use tools like Hugging Face's Evaluate library or OpenAI's Eval's framework to automate the process. This basically saves time and ensures certain consistency for you. The next step is step 6, which is test robustness and bias. How do you do this? You do this by introducing tricky examples like typos or adversarial inputs to check the model's robustness. Also, analyze whether the model's outputs are biased against certain groups. Before we conclude, let's look at one LLM benchmark dashboard that can give you a sense of how these benchmarks look like. Here is one dashboard that you could find online, and here this dashboard gives you the score on different parameters or different LLM benchmarks for each of these models that you can see here. We can see that Llama 2 with 70 billion parameters works very well on MMLU, has lower percentage on human eval, and so on and so forth. And you can actually see that GPT-4 Turbo has a very high value on human eval and pretty decently high value on MMLU as well. So when you look at these benchmarks, you get a sense of the model's capabilities and you can kind of decide which model to use for your specific task. That's how benchmarks are useful. As we've seen, benchmarks are crucial for understanding what these models can and cannot do. Whether it's testing for general language understanding or domain knowledge or ethical alignment, benchmarks help us push the boundaries of what's possible with AI. Never shy away from creating your own benchmark because some of these public benchmarks may not work for your use case. Let me know if you're working on your own benchmarks or projects or specific questions about LLMs. We'll see you in the next video. Let's now dive into the fascinating world of AI by understanding what its actual building blocks are. To explain this better, let me ask you a question. Have you ever tried to explain a complex concept to someone unfamiliar with your field? Maybe your grandfather? What was the first thing you broke down for them all? It was probably the core terms or definitions, right? The same goes for LLMs, and the core term here are called tokens. What are tokens? Now, think of tokens as the puzzle pieces of human intelligence. They can be as small as an individual letter or as large as an entire word or a phrase. Tokens are the way AI models break down and understand text. The reason for using tokens instead of full words is to make the model more efficient and flexible. Now let's look at what tokenization means. If you want to break down the word Constantinople, it can be broken down into 4 parts like con, stand, in, and opal. So all of these can individually become tokens. But why does it matter? Instead of treating this long word as one piece, the model can reuse common patterns like con and in other words, making the model more efficient. And that's why it breaks down into more tokens. Example 2 is actually breaking down technical terms. Take a word like TensorFlow, which is commonly used by programmers. The term TensorFlow can be tokenized as tensor and flow. Similarly, the word NumPy can be broken down into num plus pi. Why does it matter? Because this helps the AI model to understand technical language and recognize common prefixes and suffixes used in programming. Let's look at a third example, which is multilingual tokenization. For example, the English word for internationalization might be tokenized into internationalization. But in Japanese, the same concept might be broken down in lesser syllables like it is shown to you right now. But why does this matter? Different languages have different ways of breaking down words. And tokenization allows AI to handle multiple languages effectively. Right? And coming to the fourth example, it could be emojis and special characters. Take the emoji for family. This can be tokenized into multiple tokens because it combines several characters. Why does it matter? Emojis and special symbols aren't simple characters, and tokenization helps the model understand their structure. Now let's do this exercise. I'll give you some phrases and you can guess how many tokens this might use. Then we will check with our tokenizer tool to see how many tokens there are. The first one is the quick brown fox. This typically should have 4 tokens. Now let's take the word supercalifragilisticexpialidocious, which often can be broken into 5 to 6 tokens. Now let's take an emoji with family, and this is a single emoji and can be broken into multiple tokens based on the tokenizer you use. Now let me show you one commonly used tokenizer to just understand how these tokens work. Here is OpenAI's tokenizer link that you can access on the web. Now let's try the first example, which is the quick brown fox. It is broken this into 5 tokens, but if I don't give the space there, it's broken down into 4 tokens and 19 characteristics. And by the way, here you can also see how different models tokenize this differently. The legacy model 3 is also tokenizing its 3 tokens. 3.5 and 4 also tokenize it at 4, and this also tokenizes it at 4. Now let's look at this word. Here you can see GPT-4o has broken this down into 11 tokens, and the legacy model has had it broken into 12 tokens. So you can clearly see tokenization works very differently across different things. Now let's try it for the emoji as well. This emoji has been broken down into 14 tokens by GPT-3, and GPT-4o and 4o mini have broken it down to 11 tokens. What does this actually mean? That the more advanced models are able to work with lesser number of tokens as well. That's the main takeaway. And you can always use this tokenizer tool to figure out how many words or tokens will the AI model take as input for the task that you're giving it. If I say describe this, takes 11 tokens. So this should at least give you a sense of how tokens are used. Now let's move on to the next topic, which is context windows. Imagine you're at a dinner table. How much of the conversation can you remember at once? Now think about how an AI model processes information. A context window is essentially the amount of information an AI can hold in its memory at any given time. For example, let's try to understand context windows of different models. Let's take Shakespeare's Romeo and Juliet. The full play actually contains around 29,000 words. If you use a GPT 3.5 kind of a model, which can take 4K tokens at once, it can probably handle one act of the play at once. Now if you take GPT-4, it can handle around 32,000 tokens which means it can probably process the entire play at once. Then you can look at models like Claude, which can take up to 100,000 tokens, which means it can not only handle the entire play, but also can do the extensive commentary on the play as well. So clearly, the tokens and the model combination matters for you here. Now let's look at another example. Let's look at customer support conversations. A short duration of conversation between customers, which is around 2 to 3 minutes, works well for smaller context windows. A full day of conversation requires a larger context window. A weekly summary may need a model like Claude with 100k tokens for a context window. Now imagine each token as a second of time. GPT-3's context window is like remembering a 4-minute conversation. GPT-4 can remember a 30-minute conversation, while Claude's context window is like remembering a feature-length movie plus the director's commentary. Do you always need such big context windows? Probably not. You're using unnecessary resources sometimes. For many tasks, smaller context windows are still good enough for you to get your required output. Now, let's look at the next part, which is some of the model parameters. Let's talk about model parameters here for some time. These are the dials and knobs that fine-tune how an AI model behaves. When we say GPT-3 has 175 billion parameters, think of it as 175 billion tiny dials or knobs that adjust how the model understanding works and how it generates text. One of the first parameters to look at is called temperature. What does temperature stand for? Temperature is a parameter. If it is lower, it will tend to more precise answers, and if it is higher, it will tend to more creative answers. Now we can try this by asking your ChatGPT to work with a conservative temperature, which is 0.2, or a higher temperature, which is more creative. Let's say write a slogan for a tech startup. And the conservative thing could probably be like innovating solutions for tomorrow's challenges or building technology that matters. Temperature 8 or higher temperatures can be more creative. It can be turning coffee into code and dreams into reality, or where unicorns learn to dance with algorithms. So higher temperature turns out to be more creative. Then the next thing that you can do is try a different prompt and try the same exercise. For example, explain quantum computing. A temperature 2 would be more focused textbook style explanation about qubits and superposition, while temperature 8 might include analogies about cats being alive or dead, parallel universes, and some mind-bending possibilities. So as a practice, let's try this prompt. Describe a futuristic city in 2050. Experiment this with different temperature settings and observe the variations in your responses yourself. Try it on ChatGPT and you should get good amount of variation. Now, let's look at the practical implications of all of this. Let's bring it all together with a real world scenario. Imagine you're creating a creative writing assistant. Here is how these concepts would apply. First, tokenization. This helps you know how much content you can process. This impacts the cost as many API charge per token. Then you have context window. This determines how much of the user's previous writing the model can remember. Then you have other parameter settings, which is like high temperature that can be used for brainstorming creative ideas, low temperature for refining and editing. So that should give you a good sense of how different parameters work and how these are the building blocks of writing better prompts and using LLM models. Up next, we will actually get deeper into what prompt engineering is, and we will try to understand basic aspects of prompt engineering. In the era of conversational AI, where the ability to interact effectively with AI models like ChatGPT is becoming a core skill for managers, professionals, and innovators alike, the thing to pick up is prompt engineering. This is the science of crafting inputs or prompts to maximize outputs or responses from these AI models. Just as we trained humans to communicate clearly, concisely, and effectively, we must also learn to communicate with AI to achieve our desired outcomes. The difference between a vague prompt and a well-structured one can be the difference between a useless output and a valuable insight. In this course, you will learn how to master the art of prompt engineering by understanding the mechanics behind how AI processes language, refining your prompts for optimal results, and building a library for reusable prompts tailored to your needs. Why prompt engineering matters? Think of prompt engineering as teaching AI how to think. The way you phrase your prompt determines the accuracy of your response, the depth of the information provided, the format of the output, and the tone and style of the response or your answer. By understanding the science of prompts, you can unlock incredible efficiency in your tasks like decision-making support or content generation or data analysis or even creative brainstorming, including team communications. With this knowledge, you'll be able to achieve better results with AI, make more informed decisions, and save time and effort in your daily tasks. So, let's get started with the foundations of prompt engineering. As professionals increasingly rely on AI tools like ChatGPT, the ability to craft prompts becomes even more essential. Prompt engineering isn't just about asking questions, it's a skill that can dramatically improve the quality, accuracy, and usefulness of AI-generated outputs. In this lesson, we'll cover the foundational principles of prompt engineering and explain how ChatGPT processes prompts and provides practical techniques to improve your prompt crafting abilities. At the core, prompt engineering is a practice of crafting input prompts that guide an AI model to generate a specific and desired output or response. Unlike traditional programming, where instructions are rigid and precise, prompt engineers use conversational language to shape output of an AI model. It's more an art than science, requiring clarity, creativity, and strategy to achieve optimal outcomes. Think of prompt engineering as giving clear directions to a highly capable assistant. The better instructions, the more likely the assistant will deliver exactly what you want. So, let's look at the 3 key principles of prompt engineering. These are, in other words, sometimes called 3 C's of prompt engineering. The first is clarity. The more precise your prompt is, the better the AI's response will be. Ambiguous or vague prompts often lead to incomplete or irrelevant answers. The second thing is context. Providing background information actually helps the AI understand the task better. More context means more accurate responses. The third C is conciseness. Keep your prompts short and direct. Avoid overly long or complex instructions. A well-crafted, concise prompt leads to faster and clearer answers. Now, here is an example of applying these 3 principles. Now, let's try this prompt. Write a report on AI on the free version of ChatGPT. I have not even logged in here. I'm using the free version here. Let's try this prompt. Let's look at the response. Here, it has outlined many bullet points under many different sections and talking about what AI does, including its future prospects. Not in every case would you need so much information or in this format. Now let's try a different prompt, which is something like this. Write a 300-word report on the benefits of AI for mid-level managers. This is, first, more clear, more concise, and it also gives you the context of who your audience are. Now let's see what this gives us. You can clearly see that the size of the output changed and it is more focused and it addresses the topics that you need it to be addressing. So this is how your 3 C's, which is clarity, context and conciseness, help you with writing prompts. How does ChatGPT actually interpret these prompts? To write better prompts, it's important to understand how ChatGPT processes these inputs and generates these responses. Here is a simplified breakdown of how models actually work. Some of you are already aware of these concepts like tokenization. The first one is actually tokenization. Before ChatGPT processes input, it actually breaks down the text into tokens. Tokens are chunks of text that can be as short as a single word or a character or as long as a sequence of words. That's tokens. The second thing is context awareness. ChatGPT does not just process the last prompt, it remembers the entire conversation history. This is why providing relevant context within the prompt can enhance responses. The third thing is actually probability modeling. ChatGPT doesn't have a set database of answers. It instead uses probability modeling to predict most likely next token based on the input prompt. This prediction process shapes the tone, structure, and the depth of its response. Now, let's look at some key elements of a good prompt. When crafting a prompt, keep these 4 essential elements in mind to ensure clarity and relevance. First is instruction. Clearly state what you want ChatGPT to do. Use verbs as much as possible like write, summarize, analyze, or compare so that you are giving a clear instruction. The second thing is, of course, context. Provide relevant background information to help AI understand the task. This can include the audience, purpose, or specific details to focus on. The third thing is the format. Specify the format of the output that you want. For example, you might need bullet points or tables or lists or paragraphs. Please specify what you'd want. The fourth thing is the constraints, like setting the word limit for the document you want to be generated. Or it can be the tone, saying you want a casual conversation or a formal tone, or the style of writing, which is persuasive or informative, for example. Now, let's actually go back to our example of writing a report on AI, where we already saw when we ask ChatGPT to write a report on AI, it gave a kind of response. Now, let me give you another refined prompt with all these 4 aspects built into it and see how ChatGPT responds. Here is my new prompt. Write a 300-word business report on the benefits of AI adoption for mid-level managers, including 3 actionable recommendations. I have asked this to do specifically what we want from this particular report. When I enter this, that completely changes the output, and it talks about actionable recommendations like how we wanted, and we asked for 3, it gave us 3. It still adhered to the word limit of 300 words, and you can see the size of the document accordingly. This is how you having in mind the key elements of a good prompt, these 4 key essentials, helps you, right? Now, let's quickly summarize. The concept that we learned was prompt engineering, which essentially means the art of guiding AI through well-crafted input prompts. The next thing we looked at was tokenization. Basically, AI breaks text into tokens, affecting both response limits and costs involved. The third thing is clarity. Clear prompts actually lead to more accurate responses. The next thing we looked at was context. Providing relevant background improves the relevance of AI outputs. The next thing we looked at was conciseness. Keeping prompts short and direct enhances accuracy. And then we looked at instruction, context, format, and constraints, the key elements of crafting effective prompts. By mastering these foundations of prompt engineering, you can make your interactions with AI tools more productive and efficient. The ability to tailor prompts to specific tasks will help you get the most relevant and valuable output, making ChatGPT an indispensable tool for your professional work. In the next lesson, we'll actually look at types of prompts and when to use them to further refine your prompt engineering skills. In this lesson, we'll explore 5 core types of prompts that can be tailored to various professional scenarios. For each type, we will provide practical examples and you can immediately implement in your work to increase efficiency, improve decision making, and even spark creativity. By understanding the different types of prompts and knowing when to use them, you can essentially improve the accuracy of your AI generated outputs. You can save time by reducing the need for multiple revisions, and you can unlock creative possibilities for problem solving and idea generation. Now let's look at the first type of prompt, which is called the instructional prompts. What are instructional prompts? They are direct commands that you tell ChatGPT exactly what to do. They are best for task-oriented requests where you need a specific action or output, such as drafting an email or writing reports or summarizing documents. When do we use these prompts? We use them when you need a clearly defined output, or when time is limited and you need a quick actionable response, or when the task involves structured processes or templates. These are called instructional prompts. Now, the key tips for crafting an instructional prompt is simple. It's be specific, clearly outline the task and any necessary details that you have. Define the output format and include constraints. Output formats can be bullet points or lists or tables, etc. And your constraints can be number of words or tone or the focus area of what you want to do. Let's look at one example of an instructional prompt. Write a professional email responding to a customer complaint about delayed delivery. This is an specific instructional prompt I'm asking to be written. Does it have the length? Probably not, but it is still giving you context of who you are writing this email to and about the topic of delayed response. Let's see what it gives us. This is clearly crafted template for you to use and write an email. Here you can clearly see dear so-and-so, which is a customer name. Thank you for reaching out to us and I sincerely apologize for the delay in delivering your order, and so on and so forth. You can obviously customize this further and include the order number, you can include the customer name, you can include your details, and you can include any other compensation that you would want to give. For example, some compensation or a discount for your next purchase or free expedited delivery and things like that. These are things that can be used for accelerating your time to write a response here. Now, this is one kind of an instructional prompt that we kind of looked at. Now, let's go into the next kind of prompt, which is called an exploratory prompt. Exploratory prompts are actually open-ended questions designed to spark creativity and generate multiple ideas or opinions. They are particularly useful for brainstorming sessions or when you need to explore a problem from various angles. So again, when to use an exploratory prompt? For example, when seeking new ideas or strategies or solutions, or when analyzing potential risks or opportunities, or during the early stages of a project to gather diverse perspectives. Now, the key tips for crafting an exploratory prompt would be to do the following, which is ask open-ended questions. Use prompts that invite detailed responses rather than simple yes or no answers. Encourage multiple options. Request several ideas or alternates to broaden your own perspective on this, whatever you're asking about. Then you can use phrases like, what are some ways, or list ideas for, as some beginning to some of these prompts that you generate. Now let's quickly look at an example of an exploratory prompt. Here is an exploratory prompt I wrote. What are some innovative ways to improve team productivity in a hybrid work environment? Let's look at the kind of response it gives. you can see that the model is actually giving you a wide range of options for you to actually choose from, and then you can dig deeper into any of these possibilities if you want to go inside. So the idea here is to generate widespread set of distinct innovative strategies that can help you do the same thing, which is you want to improve team productivity, and these are so many ways that it suggests you to do it. So this is about exploratory prompts. Let's move to the third kind of prompts, which are actually called conversational prompts. Conversational prompts help you maintain a dynamic dialogue with ChatGPT. These prompts are useful for ongoing discussions where you need clarification, further elaboration, or continuous feedback. When you use these conversational prompts, some scenarios like these are helpful, especially when you want to conduct in-depth research, or when you want to break down complex concepts into simpler terms, or when refining ideas or solutions through back and forth dialogue. Conversational prompts are generally very useful. So some tips to keep in mind for crafting conversational prompts: ask follow-up questions. Ask the AI to refine its responses by probing deeper. That's the first thing. Then you can request for elaboration. If a response is too brief, ask for more details. Then you can actually encourage interaction. Invite ChatGPT to ask clarifying questions to better understanding your needs. That's about conversational prompts. Let's see an example of how a conversational prompt works. Here is a prompt I'm asking: what are the key trends in the tech industry this year? It started outlining generative AI and advanced models, AI and automation in workforce, quantum computing advancements, 5G and edge computing, AI in cybersecurity, cloud native technology, so on and so forth, blockchain, augmented reality, as some of these tech terms, right? Now, I can ask a follow-up question, which can probably be like, can you elaborate on AI's role in each of these topics? It still takes the same response structure that you had before, while elaborating more on what AI can play a role in each of these topics does. This gives you a more holistic understanding of how AI is actually useful in this particular thing. Now that you know how AI is actually used across all of these, let me just say, choose the top Now, when I've asked it a specific prompt to choose the top 5 topics with the highest impact of AI and make an executive summary out of it, this is the kind of response I get. Instead of the many topics there were, which is 13 topics that it shortlisted before, here it's focusing on the top 5 with highest impact of AI in it. So instead of looking at everything, we got started with understanding the key tech trends, and then we drill down deeper into the role of AI and the top trends where AI impacts something. So we built on the responses that the ChatGPT provided us, and then came towards a response that is fine-tuned towards our needs. And that's how conversational prompts are useful. Once you understand this, you would always be tempted to ask more questions to each response ChatGPT gives you, and that's a good thing to do. In fact, the next one is actually going to be called structured prompts. Now, this is the 4th type of prompts we're going to look at, and structured prompts basically provide specific formatting instructions to ensure the output is presented in a clear and organized format. They're useful for creating tables, reports, summaries, or checklists. When you use these structured prompts, when you need a formal structured output, for example, you need reports or you need agendas, or when you need consistency and clarity in the output that you generate, you want to have structured prompts. Or you can use such structured prompts when presenting information in a professional context. Now, what are the key tips for crafting a structured prompt? 1. Specify the output format. Use phrases like format your response as, or provide a table with, as some of your words in the prompt. And then provide example templates. If possible, offer a sample structure to guide the AI's response. Now let's look at an example for structured prompt. I've asked to create a table comparing the features of 3 project management tools. Here I've given the kind of format that I want, which is a table, and I've given 3 different tools that it needs to compare. Let's see the kind of output that we get. Clearly, the prompt has delivered a structure that we were looking out for. Now let's try another prompt just to see how this gives you a different format. Write a pros and cons list of adopting a 4-week workday. Here, list is what we are giving as a keyword for structure. And let's see what it gives. Clearly, it gives you a set of pros and set of cons as 2 separate lists of reasons why a 4-day work week is good or bad. Right? So again, you've given clear structure on how you want the output to be, and that helped you formulate your prompts. The next type of prompts are actually called clarifying prompts. Clarifying prompts are used to refine AI's output or adjust responses based on your preferences. They're essential when the initial answer isn't quite right, but you want to improve or adjust it. When do you use a clarifying prompt? When the AI's response needs more details, when the tone or style needs more adjustment, when you want alternate approaches or solutions. Clarifying prompts are also conversational in nature, just that you want to be giving more instruction rather than taking a different tangent, like how you did in conversational prompts. The key aspects here to write better clarifying prompts is one, to ask for alternatives and ask for multiple versions of a response. Or you can request for simplifications or elaborations by basically tailoring the complexity of your output to your audience, right? And then you can use phrases like, can you make this more formal? Can you rewrite this in a simpler tone? So you're actually using the same output, you're refining it rather than taking a conversational approach to build on it. That's a key difference between using a clarifying prompt and a conversational prompt. So again, let's do a quick recap of what we've looked at. We've looked at 5 different types of prompts. The first one is instructional prompts, where you ask direct and task-specific instructions. The examples can be writing emails or reports or summaries. The second one was exploratory prompts. This is used for idea generation and brainstorming. And the kind of things that you can do with this is marketing ideas or risk assessments and stuff like that. The third one that we looked at was conversational prompts. This is basically for an ongoing dialogue and clarifications and building on something that you already know a little about. This is basically good for research, breaking down complex topics. Then we looked at structured prompts, and these are useful for ensuring clear and organized outputs, like tables, reports, checklists, and so on. And then we looked at clarifying prompts, and these clarifying prompts essentially were used for refining or adjusting AI's responses. And the example task here was rephrasing and simplifying and providing alternate responses to what we have seen. That should summarize the types of prompts that we looked at. Hello folks, welcome back. Crafting effective prompts does not stop at giving clear instructions. To get the best out of a LLM like ChatGPT, you need to refine and iterate its responses through advanced prompting techniques. These strategies will help you push the AI to provide thoughtful, structured, and more valuable answers across a variety of professional scenarios. In this lesson, we'll explore 5 strategies like that will elevate your prompt engineering skills to the next level. And the first one we are going to start off with is called chain of thought prompting. So what is chain of thought prompting? It is a technique where you ask the AI to break down its thought process step by step. This encourages the AI to reason through the problem, resulting in more thoughtful, logical, and detailed responses. Instead of providing a quick, surface-level answer, the AI works through each step, helping you understand its reasoning and leading to a better solution. This is particularly useful for problem solving, decision making, and analysis, as you can imagine. So, when do you use this chain of thought prompting in the first place? You use it when you need detailed analysis or critical thinking, or for complex problem solving tasks, or when making decisions that require weighing pros and cons is required. Now, given that, let's look at some of the examples of chain of thought prompting. But even before that, like I mentioned, there are 3 different steps for chain of thought prompting. One is step-by-step reasoning. The second is intermediary steps when you need them. And third is improved accuracy. And these are the 3 characteristics that chain of thought prompting works with. Now let's look at an example. Let's start with a math example. Let's say we have a problem like this. A farmer has 3 fields. The first field produces 20 bushels of wheat. The second field produces 30 bushels. And the third produces 50 bushels. If the farmer sells each bushel for $5, how much money does the farmer make? Please explain the intermediary steps to arrive at the solution. This large statement makes it a chain of thought prompt. And let's see what the AI's response would look like. Clearly, the problem has been broken down into certain steps, and each step gives you the rationale for what the AI has done to solve that particular step and the sub-solution for each of these steps. And then you arrive at the final answer. So this prompted the AI to actually think of all the intermediary steps, put them in a structure, and then give out a solution, and therefore making chain of thought prompting a more useful scenario like this. Now let's take another example here. Instead of a math problem, now let's look at a logical problem. Here is a question that I had, which requires some bit of understanding of logic. If all roses are flowers and some flowers are red, can we conclude that some roses are red? Let's see what the AI says. It gave you the step-by-step reasoning of why this answer was as it is. Yes, we can conclude that some roses are red based on the given information. Here is the reasoning. All roses are some flowers. This means every rose is a type of a flower. Some flowers are red. This tells us that within the category of flowers, there is a subset of red flowers. Since all roses are flowers and some roses are red, it is logically possible that the subset of red flowers includes some roses. Clearly, there is some thinking going on when you ask questions like this, and this can be triggered by chain of thought prompting. Let me give you another example for chain of thought prompting that you may use in a daily scenario. Now let's take this prompt. A manager needs to schedule workers for a 7-day week. The store must have at least 2 workers every day, but only 4 workers are available: Alice, Bob, Charlie, and Diana. Each worker can work a maximum of 4 days per week. How can the manager schedule the workers to meet the requirements? Now here, you're again asking the model to break down the process of how they arrive at a solution, and therefore let's see what the response looks like. Because you've triggered chain of thought prompting here, it is calculating the total required work days to start with, then construct this schedule, and then verify the schedule, and then concludes that this particular schedule works. So as you see, clearly there is a sequence of steps that the AI will end up following the moment you say it is chain of thought prompting. Now that you understand chain of thought prompting, now let's move to the next one, which is called few shot prompting. What is few shot prompting? Basically, it involves giving AI examples within your prompt to show how you want the responses to be structured. By providing examples, you actually guide the AI towards more accurate, relevant, and precise responses. This method is particularly useful for tasks that require a specific format or style, such as reports or emails or summaries. Here is how and when to use a few shot prompting. When you need the AI to follow a specific format, or for content creation such as emails, reports, or blog posts, or to reduce errors and increase precision in your output, you can use few shot prompting. Now let's look at a few examples of few shot prompting. Here I'm going to give a language translation example where I have asked the LLM to translate sentences from English to Spanish. And I've given two examples here, and now I've given a new input in English and I've asked for the Spanish response for the same. What did the first two examples do here? They actually helped the LLM to figure out what kind of response I want and what format I wanted it. Clearly, when you see English and Spanish broken down in a sentence with a colon and the rest of the response in quotes, even your output followed the same formatting. And if you think of more complex prompts here, where you give more complex examples, it will try to follow the language structure as well and give you a response accordingly. So this is how a few shot prompting can be used. Now let's look at another math example to see how this works. I said solve simple math word problems. The first question was, if Sarah has 5 apples and buys 3 more, how many apples does she have in total? The answer was Sarah has 5 plus 3 equal to 8 apples. The next question was, John bought 4 packs of cookies and each pack contains 6 cookies. How many cookies does John have? The answer is John has 4 times 6, that is 24 cookies. Now we ask a different question that has nothing to do with cookies or that has nothing to do with apples, which is a car travels 60 miles in 2 hours. What is its average speed? Let's see what the AI responds. So here it did give you a couple of steps of calculation and then provide the final response, which is 30 miles per hour. The car travels 60 miles in 2 hours, so the average speed is, and then it gave you the formula. Like how you used multiplication here it used division, and it could figure out what to be using here. And that's the idea of having a few shot prompt, which is give it enough examples for it to learn the format and the type of output you want, and then provide that kind of output going forward. Now you can have more complex examples for few shot prompting. Now let's look at another few shot prompt example where you're asking the AI to provide interview questions for a software engineering role using the format that we've given examples below. Let's say we have given two examples of two questions here. Question 1 was about what are the key differences between process and threads in operating systems, and you gave what the objective is going to look like, and you also gave what the expected answer is going to look like. The same thing was done for other questions as well. Now let's see how the LLM actually generates responses to suit this kind of questions and come up with questions with these kind of answers. You can clearly see the objective and expected answer for each question was mentioned along with just the question. And this can be achieved because you gave a set of examples for the prompt to follow and then create new responses with. And here are the kind of output that you get. Please try it out for yourself because few shot prompting is very powerful and really fine tunes how your LLM is going to respond for the next set of questions that you ask. The next type of prompting we're going to talk about is called role-play prompting. What is role-play prompting? It involves asking your ChatGPT to take on specific personas. This technique is helpful when you need to advise or output from a particular perspective. For example, a business consultant or a career coach or a lawyer or a project manager. Each of these personas answer a question differently. By giving a persona, you are actually giving a role to the AI and you'll get more tailored and realistic responses. So, when do you use role play prompting? When you need specific advice from a particular perspective, or for simulating conversations or real world scenarios, or pushing the AI to think of directions that you've not thought of otherwise, or to enhance creativity and personalization in AI's responses. These are all reasons to opt for some kind of role-play prompting. Now let's look at some examples of role-play prompting. Let's say you're a career coach. Please provide advice on how to improve my leadership skills. Now if this is the prompt, let's see how the AI responds. Clearly, the whole response was based on how a leadership coach would actually respond. Now, to see if this is what is happening otherwise, let's just say I change my role from a career coach to a teen YouTuber and let's see the response. You can clearly see the type of responses it's giving. In one of the roles, it's saying start by listening, lead by example, communicate clearly. But for another role of a career coach, you're starting to talk about self-awareness and emotional intelligence as the first step, communication skills, decision making and problem solving, and so on and so forth. You need to notice that the rest of the prompt was very similar in both cases, and what just changed was the perspective from which you were asking the response to come from. So essentially, you can ask the AI to take up a role and from that perspective, give you a tailor-made answer for you. Now, let's look at some more examples. Let's say you're a negotiation expert and provide tips on negotiating for higher salary can be another prompt that you can try. So here is your step-by-step instructions on how to go about negotiating a higher package. The same prompt again, if given as clearly, the responses and the style of responses are different. You might see some common points between these two, but clearly the role play of you are a negotiation expert changed the formatting and the expectation set to the LLM in terms of what to respond here. Please try it out yourself. We're going to the next type of prompting, and it is going to be called iterative prompting. So, iterative prompting essentially involves refining the AI's responses through follow-up questions. Instead of settling for the first response, you can improve accuracy and relevance by continuing the dialogue with additional prompts. This technique is especially useful for complex tasks that require multiple steps or progressive refinements. So again, when do you use iterative prompting? When the initial response isn't sufficient. For complex tasks that require step-by-step clarification, you might use iterative prompting. Or you might use it to fine-tune the output through feedback. Now let's try and look at some examples of iterative prompting. Now let's take this article on how to grow beans all summer and see how we can use iterative prompting to summarize it better. Let's start by giving it article and say, summarize this article. I pasted the whole article here, gave it in quotes to know that it's the article ending, and let's enter. Now here is a full summary of that article from what ChatGPT could understand. Now let me ask it follow-up questions to refine. This is great, but it's not clear enough. I want bullet points so I can make a PPT out of it. Let me ask ChatGPT to do that. And it gave you a set of bullet points on what needs to be done, right? Now, a follow-up prompt could be, can you simplify it for non-technical audience? You further refine your response with simpler words and for non-technical audience. Then you can probably say, can you rewrite the takeaways to sound more formal? So it took the same content, made it more formal, and it kept on building from what prompts you asked in the previous iteration. So essentially, this step or this idea of iterative refinement helps you further refine the output that the prompts give you and keep asking better questions going forward to solve or refine it into a more niche and complex understanding of the answer that you need. Now that gives you some other idea of iterative refinement. Up next, we'll look at something called zero-shot or few-shot approaches, and we'll compare these two. What do these terms actually mean? You already saw few-shot prompting before, but there might be cases where you do not give examples and still ask AI to respond. These terms essentially refer to how much guidance you provide the AI before it generates a response. Zero-shot prompting is where you provide no examples and expect the AI to respond based on its training. Few-shot prompting is when you give one or more examples to help the AI understand the task. Now, when do you use zero-shot versus few-shot approaches? Obviously, when you have set format that you already know how it works, you want to go for few-shot learning. But when you do not have a set format or you're not clear about what kind of response you want, you go for zero-shot learning. And in zero-shot learning, you do not provide examples, and in few-shot learning, you provide examples. And that's going to be the main difference. So whenever you encounter something which says zero-shot learning, it essentially might just mean that you're asking more generic example rather than a specific example. For example, a zero-shot learning prompt might look like write a project update email about. It gave you a template response from what it has been trained on. Now, if I give it examples to say I only want a particular structure or I want only 3 examples, then based on your examples that you give, it will refine it and use the few-shot prompting approach. So let's quickly summarize what all we have seen today in this lesson. We've essentially seen 5 different types of promptings. The first one was called chain of thought prompting. The second one was called few-shot prompting. The third one was called role-play prompting. The fourth was iterative prompting. And the next one was called zero-shot prompting, which is a special case of few-shot prompting. Now, chain of thought prompting essentially encourages the AI to explain its reasoning, while few-shot prompting improves accuracy by providing examples. Role-play prompting generates more personalized and tailored responses. Iterative prompting refines outputs through follow-up prompts. And zero-shot prompting essentially gives different levels of guidance for the responses. That should be the end of this video. I hope you practice this, because each time you write a prompt, it will fall under some of these types of categories, and the more detail you give in your prompt, the better your output is expected to be. So think of all of these as independent methods. You can combine all of them into the same prompt. For example, you can give a role play and you can also ask it to do chain of thought together. Try those out, and I'll see you in the next video. Thank you. Using parameters to control outputs is the next topic. One of the most powerful skills in prompt engineering is the ability to control the output of ChatGPT by specifying parameters such as tone, length, style, persona, and creativity levels. By fine-tuning these parameters, you can guide the AI to produce responses that are more aligned with your professional needs. Whether it's writing a formal report, or generating a creative story, or providing technical documentation, this approach generally helps. In this lesson, we'll cover 5 key topics or techniques for controlling outputs through parameters and provide practical examples that you can adopt to different scenarios in your work. Let's start with the first one, which is controlling tone and style. The tone of a response generally refers to the emotional quality of the text, such as formal, casual, persuasive, or humorous, for example. The style refers to the way the content is delivered. For example, it can be technical, or it can be conversational, or it can be analytical, or it can just be storytelling. By specifying the tone and style in your prompt, you can ensure that the response is appropriate and suits your audience and your context. This particularly is useful when writing emails, reports, presentations, or marketing content. So why do you control tone and style again? To ensure that the response is appropriate for the target audience, to align the output with your professional or creative goals, and to make the AI's response more engaging, persuasive, or informative. Now, let's look at some example prompts on controlling the tone of the conversation. You can say, write a business proposal email in a formal tone. Let's try it out. Now we can try a prompt like, write a business proposal email in a formal tone. The fact that you mention formal tone is going to give you some kind of a response. I hope this message finds you well. I'm writing to formally present a proposal and a bunch of details. Now, can I do the same thing in casual tone? Let's look at the response. It starts with, hi, hope you're doing well. I wanted to reach out to you with a quick proposal and based on what I know about your business and things like that. You can clearly see the tone of the response changes while your prompt did not say anything else. It's always good to figure out who and why you're writing something for and decide the tone of the conversation. If I say, a prompt like this, where you're asking it to write a friendly email to your boss about your holiday, gives you an email which is informal, also friendly, and still goes beyond the idea of you drafting something to your boss. If I ask the same thing formally, you automatically see some parts of the text getting updated. Try it out yourself and notice the differences and see how certain changes in your prompt actually lead to more well-refined responses that the AI can provide to you. So that is about controlling tone and style. The next thing that we can control is the length of the response. You can control the length of ChatGPT's responses by specifying word counts, sentence limits, or levels of detail. This is useful when you need to fit content within specific constraints, such as writing summaries or essays or social media posts. Again, why do we control length? To ensure the response fits within a specific word limit or a character limit. Often, when you write essays for college admissions, you have character limits. When you write social media posts on X, you have character limits. That's when you want the help of an AI tool to take your content and fit it into it. Or this can also be used to create content that is appropriate for different formats, such as short social media posts versus detailed reports, right? So it's always good to give some kind of controlling length parameters in your stuff. For example, your prompt can itself be, summarize this report in 100 words. That gives you a concise summary that captures the key points alone. While if you give response which says, summarize this report in a detailed way, you probably get a way more broken down response with everything structured by what the ChatGPT understands as its own training structure. For example, a detailed prompt also could be, explain the history of AI in a detailed 500-word essay. This gives you a comprehensive essay covering the topic in depth. Then you can also say, list the key benefits of adopting cloud computing in bullet points. The fact that you say bullet points is also going to control the length and give it some structure and give you output in that essential format. So that's about controlling length. The next tip is setting a persona. And this is very similar to what we already saw in role play prompting. By asking ChatGPT to take on a specific persona, you can receive more tailored responses that reflect the perspective or expertise of that persona. This is especially helpful in role-specific advice or documentation. For example, if you're a legal person and want to draft something, you want to be using precise language and specific legal templates for that. This can also be used for business strategies or maybe motivational speeches as well. So how do you use this and why do you use this? We use this to tailor responses to specific professional roles and then to simulate realistic conversations with subject matter experts or to engage creativity by incorporating different viewpoints. A classic example in this case is asking ChatGPT to act as your tutor and teach you a subject. Each time you give a response, ChatGPT can act as a tutor and either push you towards the right understanding or help you understand the topics that you're not being able to comprehend properly. This is again a classic use case in this regard, and we will show you an example prompt for that. Now, even before that, we've already seen some examples in role play prompting, so try those out and you already know how to do this. It can be a career coach or it can be a consultant, and then ask it to give you specific output of a response. Let's still look at a lawyer example to see how we can do this. Say you're a lawyer and you want to draft a contract template for a freelance agreement. This is going to give you specific templates that you can further use, and it responds to you as a legal person. So setting personality is generally a good idea for any prompt you write, and it certainly refines your responses very well. And you can also take the role of a motivational speaker and write a speech for your college graduation. Now up next, let's look at using the temperature parameter for creativity and how it works. We kind of gave you some exposure to how temperature parameter works before, and what this controls is how precise your response is going to be versus how creative your response is going to be. When you have a lower temperature, your response is going to be precise. When you have a higher temperature, your response is going to be more creative. For example, if you say explain the legal implications of data privacy and you give a temperature as 0.2, then it is going to give you a very specific answer on what exactly is going to happen. Such is a prompt which requires higher amount of precision in its response. While a creative task, for example, give me some idea for a movie script, is a creative endeavor, and you want to set a temperature parameter to be higher in cases you want to use something like this. We will look at something called Playground by OpenAI, where you can control these temperature parameters and see how output varies based on how you change these temperature parameters. We'll get to that in the subsequent videos. For now, understand that temperature affects your creativity in a response, and therefore low temperature is precise, high temperature is high creativity. And then the fifth tip for better prompt output is actually specifying the style guide, which is what kind of output do you want? Do you want bullet points, or do you want tables? Do you want it formatted into paragraphs? All of that will eventually help ChatGPT understand what kind of output you're looking for and format it in such a way. Sometimes certain topics, like what we saw in chain of thought prompting, where we needed step-by-step instructions, can only come in points, and you need to specify how these points have to be written down, structured, so that you can use that output directly in whatever form you want for your business use case. So that's about this lesson, where we saw what is tone and style, we saw how to control length by specifying it. We again spoke about personas, we spoke about temperature parameter, which gives you the creativity versus precision in your responses. Then we also spoke about the fifth thing, which is output formats, ensuring the response is structured and in the desired format. With this, let's end this lesson. I'll see you in the next lesson. Thank you. Hello folks, welcome back. In this lesson, we'll look at how to avoid common prompting mistakes that you will come across. If you have ever worked with ChatGPT or similar AI tools, you know that the quality of your prompts can make or break your responses. In this lesson, we'll uncover common mistakes that can lead to confusing or irrelevant answers and explore practical ways to avoid them. By the end, you'll have the tools you need to craft prompts like a pro. So let's dive in. The first mistake is being too vague. For example, asking, "Tell me about marketing." This is far too broad. The AI does not know what aspect of marketing you're actually interested in. Maybe digital strategies or traditional marketing or trends. It's actually very unclear. What will the result be? It will be a generic response that likely misses the mark. Instead, be very specific. Here is a better prompt to try. Explain 3 key features of digital marketing strategies for small businesses, including examples of successful campaigns. Specificity gives the AI direction and results in a focused, actionable answer. That's the first mistake. The second common mistake is overloading your prompt. Imagine asking, "Write a report on AI, explain its impact on different industries, and provide a timeline of AI advancements and suggest future trends." That's a lot. There's a lot happening there. The AI might struggle to organize its response or skip important details there. Break it down into smaller parts and focused prompts. That's going to help you. For example, write a report on the impact of AI on healthcare, or provide a timeline of AI advancements from 2000 to 2025, or suggest 3 future trends in AI technology. Smaller prompts actually lead to clearer and more detailed responses. The third mistake is not providing enough context. For instance, if you ask, "Write a project update," the AI has no idea which project or audience you're referring to. Without context, you will get a generic response. Instead, include details. A better prompt would be, "Write a project update email for the marketing team, summarizing the progress of our new website launch and highlighting any new challenges." This ensures the response is relevant and actionable. And that's what you want at the end of the day. And another common mistake is ignoring output formatting. For instance, if you ask, "Explain the benefits of remote work," the AI might give you a long, unstructured paragraph. Specify what you need. For example, list 5 benefits of remote work in bullet points. This makes the response easy to read and fits your needs perfectly. And finally, mistake 5. It's not iterating on your response. Many users stop at the first answer, even if it is generic. For example, asking for a product description and accepting the initial response. Instead, treat the process like a conversation. Ask for alternatives, refine the tone, or request a more refined answer and additional details. Think of ChatGPT as your assistant, where you want to probe more information in a format that you want, and you need to ask repetitive questions sometimes. For instance, this could be, "Write a product description for our new smartwatch," or follow up with, "Make it more engaging and add a call to action." Then you can probably have something like, "Now make it more formal for a press release." These iterations actually allow you to tailor the response to your exact needs. So here's a quick recap of the mistakes and their solutions. Being too vague, stop that. Be specific. Asking for too much? No, break it down. Lacking context? Add background information as much as possible. Don't ignore formatting and specify the structure. If you're not iterating, refine through follow-up questions, and that is going to give you better responses overall. These are the common mistakes that you want to avoid, right? To summarize, follow the best practices. Be clear and specific. Keep context. Provide constraints like word limits or tone. Iterate and refine. And specify your desired format. Hello folks, welcome back. If you frequently use AI tools like ChatGPT, having something called a prompt library can make you work faster and be more consistent and scale your work. Think of it as a collection of ready-to-use templates for common tasks. In this lesson, we will talk about why you need a prompt library, how to build one, and the best practices for using it efficiently. A prompt library saves time by reducing the need to create new prompts from scratch. It ensures consistency in your communication and it helps you scale your AI interactions for different tasks. Whether it's emails, brainstorming ideas, or solving business problems, having a library of well-structured prompts can be a game changer for you. So, when is prompt library actually most useful? It's actually ideal for your everyday tasks like writing emails and meeting summaries, brainstorming marketing ideas, solving problems, making decisions, and even improving collaboration within teams. By categorizing prompts into task-specific groups, you can retrieve the right prompt quickly and boost your productivity. So, to organize your prompt library, divide it into categories like email templates or reports or brainstorming or decision making or problem solving, and you can also have it by the domain of work that you have like marketing or branding or personal productivity. For email templates, a useful prompt might be like write a follow-up email for a business meeting or after a business meeting. For decision making, you could use something like list the pros and cons of adopting a hybrid work model, and organizing prompts makes them actually easily accessible and you can apply them better. Let's build your own prompt library in 4 easy steps. First, identify the common tasks you frequently perform with ChatGPT. For instance, could be writing reports or drafting emails or solving business challenges. The second could be create reusable prompts that can apply to multiple situations. For example, write a professional follow-up email after a business meeting summarizing the key points and next steps. The third prompt could be categorize your prompts into themes such as brainstorming or reports or decision making. And the fourth step would be refine your prompts over time based on the feedback you receive from ChatGPT. For instance, if you are initially asking for a simple report summary, you can refine it to request a 300-word executive summary highlighting key trends and recommendations. Let's walk through a few examples for a sample prompt library. For example, you could have prompts like write a professional follow-up email after a business meeting, an example that we just spoke about, or we could have draft an apology email for delayed shipment offering compensation, or we could do something like write a 300-word project update for stakeholders covering progress and challenges. These are all just simple examples of it. Let me now show you a prompt library that I've created for myself using some of the resources on the internet. Here you see I've organized these prompts into different categories. Here is a category heading. I call what type of category am I going to use this prompt for. For example, this is for SEO, this is for social media strategy, and the level of prompt, if it is advanced or intermediate, and this tells you kind of how difficult these prompts are. Now I have all the way up to 1,000 prompts, and some of them are about productivity. For example, here you can see summarize the key points from meeting notes into a concise bullet point list is one of the prompts I have. Create a prioritized to-do list for my project based on the following goals, and you can list your goals. So having some kind of a prompt library like this is actually super useful for you, especially when you want to reuse some of these prompts on a frequent basis and then come up with meaningful output using AI. Today, I'll introduce you a tool called OpenAI's Playground, which is a fantastic tool for experimentation with AI models like GPT-4. Whether you're exploring AI for the first time or prototyping an idea, the Playground is an accessible and user-friendly platform to help you understand what AI can actually do. So let's start by talking about why Playground is actually useful. Firstly, it's great for exploring AI capabilities. You can actually test what AI models like GPT-4 can do in real time. And then you can actually customize outputs as well. Like you can adjust the settings like temperature or max tokens or tweak the model's behavior. Third, you can do some prototyping. You can quickly validate ideas without any code using the Playground. The fourth use is actually prompt engineering and learning it properly. So far, you've picked up different ideas of prompting, but Playground actually helps you go through different methods that you've learned, apply them, and see how different phrasing changes the model's responses. So it is going to be an incredibly useful tool for prompt engineering learning. And then another use could be understanding model limitations. So you can identify where the model excels or where it might need more guidance. But enough talking, let's dive deep into how to do this with Playground itself, right? So for this, you first need to create an account on OpenAI's website. Go to this website called platform.openai.com, and if you don't have an account, sign up. If you already have an account, log in. I'm logging in my account here. And then you can go to this website called platform.openai.com/playground. Or you can just Google search it, OpenAI Playground. And you should get an interface that looks something like this, where you can give something called a system prompt, you can give user prompt, and you can also have a bunch of responses or presets for your model parameters here. So what does this essentially do? First things first, let's try choosing the model that you want the response from. Here is where you choose the different models available to you. So clearly some of them are reasoning models, some of them are daily use case models, and you can choose the model that you want to try. Let's just use ChatGPT 4o mini for now. And you say the output format that you want is a text or JSON object or the JSON schema that you can define. Then you can add more functions here, which is the model will basically intelligently decide to call functions based on the input that you give. This is another thing that you can do. And more importantly, you can do something called model configurations here, where you can set the temperature parameter, you can set max tokens, you can set stop sequences. Here is a stop sequence I used. After every prompt's response, you can get something like this. And here are other parameters that you can set, like a frequency penalty, presence penalty, and top P. I will describe them in a bit. So let's first understand what is a system message and what is a user message. A system message is something like telling the role or giving the overall context to your LLM. This is where you can set your personality or role play, right? Here is what I told the system. This is how it's going to behave for the rest of the prompting session that you're going to do. Now, the user message itself can be, "Hi, now let's see what response the model gives you if you run this." So it's asking you to provide details about the dispute and you can start answering thereof. What if you say you are say this was my system prompt, so I am setting the system to be this, and now I run the same user prompt, which is you can directly see how changing the role directly affected the prompt response here. So essentially in this playground you can vary the system prompt and the user prompt to see the kind of responses. Now if I do the same prompt but with a different temperature parameter which is set to 1 right now, you can go higher for more creative responses and lower for more precise responses. Now let's see the same prompt leading to what kind of output does it give essentially. It still gave you a structured thing. What if I increase the temperature parameter and run the same prompt? You can see it is even creating some gibberish text that does not even exist for this context. Clearly, higher temperature is not working for a context like this. This should also give you a sense of where the model is failing. Let's just stop it and set back the temperature parameter to around 1, which is the default, and ask it again. This gave you 6 steps, and let's compare it with the temperature parameter, which is even lower. It gave you 5 different steps and it asked you for responses. Now, what if I set the max tokens to just around 100 and try the same text? This is all your response will look like because your max token limit has reached. So your response is terminated. So that's another thing to actually try out and see how your model is going to respond each time you ask a prompt. And for that given prompt, if you set certain parameters, what is the response going to look like? Here it gave you a partial answer and not a full answer because it did not have enough tokens to respond with. Now, let me give you again a brief context about what each of these parameters do. The first one is temperature parameter, and it helps you control the creativity and the precision of your prompt. Then you have max tokens where you determine how long the response will be. A token is roughly equivalent to a word, like you already know, though it varies sometimes. For example, if you set 150 as a token size, that means the model can generate somewhere around 150 words as a response. Then we have something called top P that you see here. So top P, this is just another way of controlling randomness. It defines a cumulative probability of the model choices. Essentially, that higher values will allow model to consider more diverse words. Lower values here will basically result in more predictable answers. So your top P and temperature kind of are similar to each other in terms of how randomness is affected by the values you select. Temperature is more about creativity versus precision. Top P is more about the cumulative probability for the model's choices, which basically affects how random the answers can end up being. Not creative, it's random here. And then you have something called frequency penalty, which is here, which is it reduces the likelihood of repeating words or phrases in your output. So this makes sure if it is using or repeating certain phrases, there's a penalty for it, and you can set the penalty very high, then it will not repeat any words. If the penalty is low, then it can repeat certain words. And then there is presence penalty, which is increase the model's likelihood of introducing new topics or ideas in the response. So if you set this parameter higher, which means anything that is beyond the scope of what you've asked for will be penalized if the model gives you a response like that. If this is 0, then there is no penalty for the model to come up with newer kind of content which may not be directly related to what exactly you're asking. So these are the type of parameters that you can choose and you can preset, and you can choose what kind of a role you want. You set your system prompt as something, and you set your user prompt as a response here, and then you can run these. Once you do this, you'll get a good sense of what parameters are actually working for your particular business case that you're trying to use ChatGPT for. And this should also tell you that while this is a great tool to learn, for implementation, you might want to go back and use your regular ChatGPT. This is where you pick up how to create better prompts. And in certain cases, you want to prototype something and create an application for something, you can actually figure out what are the best parameters to use. And you can use APIs from OpenAI to actually integrate it back into your application that you're building. That way, you know what's happening and you have a foolproof mechanism of taking it and using it elsewhere. I hope that gives you a good sense of how to use Playground. Try it out. Here is where you can get creative with your prompts. You can refine your prompts. You can set parameters and see how the output is going to vary.